Hello everyone. Today is the first lesson in Geometry A, and if you'll turn in your books to page 27, Introducing Geometry. So the first thing you're going to need to do is you're going to need to start a notebook with definitions, and then we'll add conjectures to that, and we'll discuss what a conjecture is when we get to that point. But definitions are kind of hard to explain what they are, but it's a statement that clarifies or explains the meaning of a word or a phrase. However, we have three terms in geometry that will remain undefined because I will describe what each one of them is, but they don't specifically have definitions. So if you're ever asked, what are the three terms in geometry that are undefined, it would be point, line, and a plane. So a point is a location, and we use a dot to represent that location. The point is the most basic building block of geometry, and when we draw the dot or the point to locate the location, we label it with a capital letter. The next thing is a line, and a line is an infinite collection of points. And the line goes in each direction, opposite directions to infinity. We use 2 points to define a line because it takes 2 points to determine which direction a line would be going in. So you could call this line AB. You put a line on the top of it with arrows going in both directions so that it won't be confused with a segment or a ray. You can also label a line with one letter. For example, if this had an M down here, we would call it line M. So both of those are accurate ways of defining or representing lines. Now, if you wanted to represent the measure of a line, you can't define the measure of a line because it goes to infinity in both directions. The other term that doesn't have a specific definition is a plane. And when we draw a representation for a plane, we typically make it into a parallelogram, which we'll go over the properties of that much later in the course. A plane, you can think of a plane as a page in your textbook, a piece of paper, except that it goes to infinity in both directions. In all 4 directions, the plane goes that far. It doesn't have any thickness, though. So even though we let the piece of paper represent a plane, technically it doesn't have even the thickness of a sheet of paper. And we usually will give a plane just a single letter. So that would be plane C. All right, so that's point, line, and plane. If you look on page 29, there's a BC cartoon that sort of goes through the hardships of understanding the fact that point, line, and plane don't have specific definitions other than what we just went over. All right, so back to definitions. We don't have definitions for these 3 terms, but it's really kind of funny because those 3 terms are used to define everything in geometry. So we don't define them specifically, but they're used over and over again in definitions in geometry. So the first definition that you're going to have in your notebook, I would definitely put point, line, and plane in my notebook, but just note that the definitions are not really definitions, they're just explanations for those 3 terms. The first definition is collinear. Okay, I would say that these 3 points are collinear because they are all contained in the same straight line. All right, so points A, B, and C are collinear. Coplanar, write that on here. is just what it sounds like now that you know what collinear is. Coplanar points are points that are all in the same plane. So, for example, anything that you can draw on your sheet of paper are coplanar because they're all contained in the same plane. All right, now then, turn to page 30. We talk a little bit about the measure of a line segment, and then we'll talk about congruence of line segments, how to find midpoints of line segments. So if I draw a line segment and call it AB, and I want to locate the midpoint, I'll just call it M. If I measure this thing, and this comes out to be 1.5 inches, then this would also have to be 1.5 inches if M is the midpoint. So the midpoint of a segment divides it into two congruent line segments. They have the same measure. So we say that two segments are congruent if and only if their measures are exactly the same. All right. Another one that they show you in figure B on page 30 is a line that's not drawn either perpendicular or parallel to the x and y axis, yet they show us that MN is 5 units, or the measure of MN is 5 units. So that's the way you write, the two different ways that you write the measure of something. So for example, up here in this example, I could say that AM equals 1.5 inches. And the other way I could say it is the measure of AM is 1.5 inches. Either one of these mean the same thing. Okay, so if you put the bar on the top, you don't need the measure in front. And if you don't put the bar on the top, then you need to write the measure of AM is equal to 1.5 inches or whatever the amount is. All right, now we talk about congruence. If segments have the same measure, and this applies to angles also, if angles have the same measure, then they're said to be congruent. So up at the top here, we have that AM, segment AM is 1.5 inches, so it's congruent to segment BM, which is also 1.5 inches. And you notice the congruent symbol is an equals with a little tilde on the top. That means it's congruent to. It has the same measure as. Okay, there's another way that we can indicate that segments or angles are congruent, and it's by the use of tick marks. So over on page 31, we have this diagram that says that's A, that's B, this is C, and then it has a tick mark here and a tick mark here. That means that AB is congruent to CB. Okay, the measures are the same. So if they have tick marks, it indicates that they have the same measures. All right, so the example down at the bottom of the page, we have this two segments that intersect. And this is C, D, E, F, G. And it tells us that CD is 2 centimeters. And DF is also 2 centimeters. And then we have this triangle, and this has one tick mark, H, J, K, L, and then these have 3 tick marks. And then it asks us questions. Oh, and then we have this segment with no markings on it at all. It looks like N is the midpoint of MP, but there's nothing there to indicate that. So we can never make assumptions in geometry without them giving us enough information to know that they're accurate. So letter A says name each midpoint and the segment it bisects. All right, so I know that F is the midpoint, and it bisects segment CD because this is congruent to this. So it bisects CD. Over here in this diagram, what do we know there is the midpoint? Well, there's nothing here. That's one side. That's all that's saying is this is congruent to this. So those two sides are equal. But over here, since we have 3 tick marks here, 3 tick marks here, that means that this segment is equal to or congruent to this one. So that would make K the midpoint, and the segment that it bisects or cuts in half is JL. All right, then letter B says name all of the congruent segments. Use the congruent symbol to write your answers. All right, so letter B, congruent segments. That would be CF is congruent to DF. And what else? HJ is congruent to HL. And finally, JK is congruent to LK. All right, so that's all the congruent segments there. Now, if going back to this, remember we can't make any statement about a midpoint or congruent segments because there's nothing there to indicate it. Even though it looks like that could be the case, there's nothing there to indicate it. All right, over on page 32, the next definition is array. Array has one endpoint, and it goes in a direction to infinity. So I can name this as ray AB and put the arrow going that way because that's the direction it goes. If I want to name it as ray BA, I would have to put the arrow going this way because the ray starts at A and goes through B in that direction. So it's okay to write it either way as long as you get the arrow going in the right direction. Sometimes a ray is also called a half line. I'm not sure why, unless it's because it only goes to infinity in one direction instead of two. But just in case you were to see this on a standardized test, you'll be aware that a ray has one endpoint and it goes through a point in one direction. So a half line, a line goes in both directions to infinity. A half line only goes in one direction to infinity. The other end is an endpoint. Okay, that was just added information in case you ever see that term, half line. And the last thing in this section is when we graph points on an XY coordinate system, like if we had a point here and a point here, each one of those has an X value and a Y value. So if we want to find the midpoint of the segment drawn between those two, the formula is this: X1 plus X2 divided by 2, so it's the average of the X's, comma, Y1 plus Y2 divided by 2. So to find the midpoint, you add the X's, divide by 2, and you add the Y's and divide by 2. And that'll find the point that's halfway between any 2 points on the XY coordinate system. Okay, so now you're ready to go back and do the exercises. They're listed in Canvas, exactly which ones you have to do, from page 33 to 35, and then you also have the exercises on page 37 that use the midpoint. All right, thank you.